Now that we know how to find common denominators, let's actually do some of these. Okay, we want to add or subtract in every example. Here, denominators are 2xy and 4x. Not the same, so we need to find a least common denominator. Well, noticing that 4 factors as 2 squared, what factors show up in our least common denominator? We have 2's, x's, y's, and that's everything. What exponent do we need? Well, 2 to the first or 2 to the second? We need 2 to the second. X, we just need x. Y and nothing, we need y. So 2 squared is 4, so our least common denominator is 4xy. Okay, so now I need to rewrite these so that each of these fractions are equivalent to what they are now, but they look different, meaning they have 4xy as their denominator. Okay, well, I have 3 over 2xy. I need to turn the 2xy into a 4xy, so I have to multiply by 2 to get there, which, remember, means I need to multiply the numerator by 2 also. Okay, now the other one, 5y over 4x. To turn 4xy, or to turn 4x into 4xy, the y is what's missing. I need a y in there, so I'll have to multiply by y over y. Okay? So after I do this multiplication, I have 6 over 4xy plus 5y squared over 4xy. And now that the denominators are equal, I can just add the numerators. So I have 6 plus 5y squared over 4xy. Okay? Next one. Again, denominators are different. I need a common denominator. So I factor my denominators, but p minus 3 and p plus 2 don't factor anymore than they already are. They're prime. So what's my common denominator? Well, what factors show up? P minus 3 and p plus 2. That's my common denominator. So that means when I convert these, I'll have p over p minus 3. And I'll put this in parentheses so that there's no confusion after we multiply. I have p minus 3. I need p minus 3 times p plus 2. So what I need to multiply by is the p plus 2. And I need it on top to keep the same value. Minus, I have 1 over p plus 2. Again, I'll put that p plus 2 in parentheses. I have the p plus 2, so I need the p minus 3. So let's multiply this. I have p squared plus 2p over p minus 3 times p plus 2. You can multiply that out, but it's easier to just leave it like this. Minus p minus 3 over p plus 2 times p minus 3. And now I subtract numerators. So p squared, there's nothing to match it here. 2p minus p is plus 1p. Minus a negative 3 is plus 3. Still over my common denominator. Okay? Finally, this one, and then we'll move on to some slightly more complicated examples. We need a common denominator. My denominators are x minus 1 and 1 minus x. Okay, well, I'm kind of running out of room up here. Let's move this down here. Common denominator is going to be, well, I'm going to need an x minus 1 factor. And it looks like I need a 1 minus x factor. But actually, these two are the same except that the signs on all the terms are different, which means if I factor a negative 1 out of this, I just have my x minus 1 again. So for my common denominator, I can just use x minus 1. Or I could use negative 1 times x minus 1. You can always use the negative 1 or not. It doesn't matter. So what happens then is to get these to have the common denominator, I have my 4 over x minus 1. Already has the common denominator. Plus 3 over 1 minus x. Doesn't have the common denominator. I need to multiply that by a negative 1 in order to get x minus 1. So I'll multiply by a negative 1 in the top and the bottom. So I end up with 4 over x minus 1 plus a negative 3 over x minus 1. 4 and negative 3 gives me 1. 1 over x minus 1. If we look at these two examples now, in these two examples we are going to have to factor our polynomial denominators and not simply by factoring out a negative 1. Okay. T squared minus t minus 2 factors as t minus 2 times t plus 1. Okay? And t squared plus 4t plus 3 factors as t plus 1 times t plus 3. If you're not sure how we got these factorizations, go back and review your factoring. Now, the least common denominator. Well, what factors show up? I've got a t minus 2. I've got a t plus 1. I've got a t plus 1 here, already covered. I've got a t plus 3. The highest exponent on any of those factors is a 1. So this is my least common denominator. Okay? So, how can I rewrite this with this denominator? Well, I have t minus 2 and I have t plus 1. I simply need the t plus 3. So I'm going to multiply the top and the bottom by t plus 3. Okay. Here, similar story. I have the t plus 1. I have the t plus 3. What I need is the t minus 2. So I multiply top and bottom by t minus 2. Okay? Now the denominators are the same. From there, it's a matter of just expanding these numerators and adding them together. And so we get let me just rewrite this as 3t plus 9, and I'll rewrite this as 2t minus 4. So when I add them, what I end up with is 5t plus 5 over t minus 2 times t plus 1 times t plus 3. And in this one, I can actually do a little bit of simplifying now. Because if I factor that 5 out, that's 5 times t plus 1. And so I've got a t plus 1 in the top and the bottom that I can divide out. And I end up with just 5 over t minus 2 times t plus 3. Okay? So occasionally, you will be able to do a little reducing at the end. Not always, though. This one is a similar story. When we factor the denominators, we have m plus 4 times m minus 4. And for this denominator, I have m plus 4 times m plus 4, or m plus 4 squared. Least common denominator, then, is I have an m plus 4, m minus 4, m plus 4 already covered. Highest exponent on m plus 4 is 2, and on m minus 4 is just 1. Okay? So, I rewrite these by multiplying by what's missing. So, I have m plus 4, I have m minus 4, but I need m plus 4 squared. So I have to multiply top and bottom by an m plus 4. Okay. And here I have m plus 4 squared, but I need an m minus 4. So I multiply top and bottom by m minus 4. Okay? So what I'm going to do is multiply m times m plus 4 is m squared plus 4m. And here, just so I don't make a mistake, I'm going to change this subtraction to adding a negative 4. So negative 4 distributed through is going to be negative 4m plus 16. Okay? So when I add the numerators, I will have m squared, 4m minus 4m is 0, plus 16 over my common denominator. Nothing there is going to cancel because m squared plus 16 will not even factor. It's a sum of squares. So that's the final answer.